Hello and good evening. So I'm here to present single and three-phase transformer and its principles. So here we go. So here, as you can see, we will start with single phase voltage. So what does a single phase voltage transformer does? So a single phase voltage transformer basically consists of two electrical coils, two electrical coils as you can see in the figure, in which there is a primary winding, okay, and a secondary winding. So generally, the primary winding is the one that receives or is connected to the input voltage supply and converts or transforms electrical power into a magnetic field, in which you can see in the transformer core. The VP, or in the primary winding, wherein the voltage will flow, will be transferred to the transformer core, and then in turn will transform the electrical power into a magnetic field. So since there is a coil, then there is a windings. So there is a primary number of primary windings and secondary windings. And however, the secondary winding generally it is the one that is connected to the secondary circuit. So as you can see here, the difference in voltage between the primary and the secondary winding is achieved by changing the number of coils. As I said earlier, there is NP, where is the primary coil, a number of primary coils, and secondary winding coils. So since the transformer is basically a linear device, a ratio now exists between the number of turns of the primary coil divided by the number of turns of the secondary coil. This ratio is called ratio of transformation. So it is commonly known as turn ratio. So here we can see here that when a transformer is used to increase the voltage on its secondary winding with respect to the primary, it is called a step-up transformer. And while when it is used to decrease the voltage on the secondary winding with respect to the primary, it is called step-down transformer. So yeah, as I said earlier, the difference in voltage between primary and the secondary windings is achieved by changing the number of coils from the primary and the secondary coils or windings. So here is an example. A voltage transformer has 1,500 turns of wire on its primary coil and 500 turns of wire for its secondary coil. So what will be the turns ratio of the transformer? So this is the first example, and here is the way wherein we can solve this one. So let me just grab my pen and let's solve this. So first, you do have to know the equation for turns ratio. So for the turns ratio, which can be seen here below, it is dr is equal to np over ns if the given was turns. So as you can see here, we will use dr, or turn ratio, is equal to np, the primary, and the ns. So the np is 1,500 turns, and our secondary coils, which is the NS, will be 500 turns. This will be 500. In turn, we will have this answer, 3 over 1, or simply 3 is to 1. So what does this mean? So this ratio of 3 is to 1 simply means that there are 3 primary windings, 3 primary windings for every 1 secondary winding. So as the ratio moves from a larger number on the left to a smaller number on the right, the primary voltage is therefore stepped down in value as shown. So earlier, we have this. And since we obtain 3 is to 1, then this single phase transformer is called a step down and the value shown. So here concludes the basics of the single phase voltage transformer. Oh, this one is correct. Incorrect, actually. This one is 3. Now for the 3-phase voltage transformers. 3 voltage transformers. As you can see, 3-phase are used for electrical power generation, transmission, and distribution, as well as for all industrial uses. 3-phase supplies have many electrical advantages over single-phase power when considering 3-phase transformers. We have to deal with 3 alternating voltages differing in phase time by 120 degrees, shown here. So, oops. So a 3-phase transformer is constructed by either connecting together 3-phase transformer, therefore forming a so-called 3-phase transformer bank, or by using one pre-assembled and balanced 3-phase transformer which consists of 3-phase pairs of windings mounted onto single laminated core. So here we do have some examples on how 3-phase transformers are connected. So here, as you can see, the different types: delta mesh, star Y, or Y, the mesh ones, and the interconnected ones, interconnected stars. So here are the equations that we will use in order for us to obtain the line voltage, line current on each configurations. So as you can see, for delta, we will use this one, and so on and so forth. So for an example, the primary winding of a delta star connected via 50 VA transformer is supplied with a 100 volt 50 hertz 3-phase supply. So if the transformer has 500 turns on the primary and 100 turns on the secondary winding, calculate the secondary side voltages and currents. Given transformer rating, this one, 51 VA, supply voltage which is 100 volts, primary turns which is 500 turns, and secondary turns which is 100 turns. So how do we solve this? So how do we solve this? So okay, so let's start with determining the N. which consists of ns over np. This can still be ratio that we solved earlier. So this one has 100 over 500. So n will be equal to 0.2. So that's how we start solving this problem, by obtaining this answer. So next, we will have to obtain the V load or VL per second or a second. So to be able to obtain that, we do have the equations given. So this one, for the delta, we will use square root of 3 times n times VL. So square root of 3 times n, which is 0.2, multiplied by VL, or this one is VL it's not second, it's secondary, VL primary. Since we are to compute secondary side voltages. So this is the equation, square root of 3 times n times VL, VL primary. So square root of 3 multiplied by 0.2 multiplied by 100 volts, which is the primary. So it will be equal to 34.64 volts. So that's how we obtain the secondary side voltages, or VL. So next we will have to compute for the secondary voltage on VE. So for that, we do have to use VL over square root of 3. This is for the secondary voltage. So for that, we will have 34.64 over square root of 3. Now the answer for that is 20 volts. Now we already have obtained all the secondary side voltages that the problem requires. So the VL P sec is equal to 20, and VL sec is equal to 34.64 volts. Now, next we will have to obtain the current. Now for the current, we will have to use the equation IL primary, right, equals to VA over square root of 3, square root of 3, VL prime, or VL primary. This will be equal to 50 50 over square root of 3 multiplied by 100. So this will be 0.289 amperes. Now, since we have obtained this value, we can now compute for the secondary currents. So for the I set, we will be using IL primary, which we obtained earlier, IL pri over square root of 3 multiplied by n, which is 0.2. So 0.289 over square root of 3 multiplied by 0.2. This will give us an answer of 0.834 amps. So this value will be the secondary current. So for the secondary side of the transformer, so it supplies a line voltage VL of about 35 volts, giving a phase voltage of VP of 20 volts at 0.834 amperes. So that concludes my discussion. Thank you for listening and have a good day.